All right, now we have diameter of a binary tree. Okay. We did something else with binary trees before. Given the root of a binary tree, return the length of the diameter of the tree. The diameter of a binary tree is the length of the longest path between any two nodes in a tree. This path may or may not pass through the root. The length of the path between two nodes is represented by the number of edges between them. Okay, so 1, 2, 3, 4. Oh, I'm counting the edges. 1, 2, 3. 1, 2, 3. Okay, this screams out for a recursive solution, as most binary tree solutions do. This is problem 543, so goes right over here. LC underscore 0543. Obstruct solution. Okay. Return 0. Test mod. Example 1. So that's right. We also need to import tree node. So let tree is equal to tree node from vec bang 1, 2, 3, 4, 5. And then we're going to assert that solution diameter of binary tree is equal to 3. And that should fail. I failed the wrong way because I forgot to put ampersand here. There we go. Okay, so we were expecting 3 and we got 0. All right, so let's figure out how to calculate the diameter of a binary tree. The longest path between any two nodes in a tree. So can we just base it off the height of the left side and the right side? Right, the height of this side is 2, and the height of this side is 1. So can we just add the height of the left and height of the right and say, okay, that's our diameter? If we recurse down, then our diameter here is 1, or 2, sorry. And then we pop up. Okay, so I think we actually need to say what's the diameter of the subtrees and figure out. Okay. I think it's some sort of combination between the height and the subtree's diameter. The subtree's height plus the subtree's diameter in some combination. 0, 1 has a 1. Sorry, 1, 2 has a 1. This is 3. Because I don't think it's just the height of this plus the height of that. I don't think you can do it that way. Let's try it that way and then see what tests fail, and then we can learn from that mistake. So let's create a little function just called height, which takes in a root of an option rc ref cell tree node, and just returns the height of the tree starting from that root, which should be straightforward because it's just self height of the left maxed with the self height of the right. Right, we can say let left equals root. Let me call root. I'll call it root. Borrow left, and then we have right And then we can just say return the self height of, should these be references too? Yeah, I think they need to be references if we're going to call self height, because that's an option. Oh, that says unknown. Why is that unknown? All right, well, let's let the compiler tell me why that's unknown. Self height left, max of self height right. And that's the height of this subnode. Oh, right, because unwrap. Oh, so it's unwrap, we got to check. Okay, so let, if let some, let's say node equals root. If it's none, then we'll just return 0. But meanwhile, we'll just change these to node. All right, so that builds. And then what we can do is just say, let's just try returning self height of root dot unwrap. Oh, yeah, I want to add the left and the right and make that the height of the tree. Okay, so we can say if let some node equals root, return self height of node dot borrow left plus self height node dot borrow dot right. And there's going to be a reason this doesn't work. L0. And I can't think of the reason off the top of my head because it's not just summing up the heights. Right, reference. And it's still 0. Oh, I have to add 1. Duh. Okay, so that did actually pass this test. Let's try this example and see if how well this works. So this height is 1, or sorry, this diameter is 1. Okay, so that passes. I don't know where it is. It's in here somewhere. There it is. Okay. There's got to be some reason this doesn't work though. Let's find out why. Let's paste that in. Yeah, okay. So we have this complicated tree. Let's add this as a test case. Our code outputs 7, but it should be 8. Okay. Wrong answer 1. Let tree equals tree node from vec bang this thing. And all the nulls change to I32 min. Because that's the way we wrote our code. And then we're going to say assert EQ solution, diameter of binary tree, and we're expecting 8, and we got 7. So let's reproduce that fail. Oh, that's interesting. This time it says 5. Here I output 7. It's the same code. That's weird. Let me try printing out this tree so we can see what it looks like. I don't have a good handle on it. I don't have a good way to print it out, unfortunately. I can debug it out and then we can kind of parse the mess. That's here? Not really. Left is -7. The left of that is none. The right of that is none. The right side of this node is -3. But the left side of... Oh, I can't. Anyway, so we need to come up with 8 somehow, and I don't know what this tree looks like. So that's a problem. Let's look at the definition again. Length of path between two nodes is represented by the number of edges between them. Diameter of binary tree is the length of the longest path between any two nodes of the tree. So we do want the height in there. We just need to calculate the diameter of a tree as, oh, maybe it's going to be the height of the subnode, or the height of the bigger subnode. If it's the height of the bigger subnode, we can call that the diameter of the subnode. And then when you get down to here, the leaf diameter is going to be 0. And then we can just add in the heights as we go up. So why don't we try that? If I create a separate function here called diameter, which takes in a root, let's just do this. Call it diameter. Here's what I'm thinking, is that we can do this here. We can go left height is equal to the height of node borrow left, and then the right height is the height of the right node, and then we can recursively call diameter. With the same values here, node borrow left, and change that to right, and then it'll be it'll be this same calculation here, the height, but we're going to also use the diameter. We're going to say, like, if the diameter, whichever one of these has a bigger diameter, we'll use that instead. And if that's bigger than this sum, then we'll use that instead. So we can actually say max left diam dot max right diam. And if we do it this way, then we always take the largest of whatever's. If the diameter is bigger, then we pick the diameter. If the diameter is smaller, then we pick the sum of the heights. And the height automatically adds the 1 in there. And this also handles the null. So actually, this top one just becomes self-diameter of root, because this already handles the none case here. Right? This way we pick the maximum of the right diameter or the left diameter or the sum of the heights. Whichever one's biggest is the one we pass up to the next level. All right, let's see if that passes our test. It does not, because I didn't put an I32 here. Now we're only getting 6. I wonder if we're building the tree wrong. I thought I was building this tree correctly because of all the other tests we did. Because before I made that change, we had the wrong value here, which meant that, I mean, because I can't think of what else we need to do besides taking the maximum of whatever we find is. I bet we're building the tree wrong. But the tree building code is straightforward. Right, index times 2 plus 1 and index times 2 plus 2. Okay. I'm going to submit this, and then we can figure out whether there's a bug here or if there's a bug in the tree building code. Because I should try to print this out cleaner, right? Okay, so that works. That means we're building the tree wrong. And the reason I suspected that before is because we got the value different. This value is 5, remember? And the incorrect answer had a 7. So let's commit these changes, even though this test fails. And then we need to fix our tree code, apparently. Git add source, git commit -m. Oh, git status, git commit -m problem 543 diameter of binary tree. I don't know why there's no in there. All right, let's fix our tree code. Source utils tree. I think one thing we could do is just see if we can print it out in a nicer way. This says derived debug. Can we implement display for tree node and then just print it out? Let's try that. How do you implement display? It's like you need display and you need formatter. Rust impl display. Standard format, use format display, and it comes out with a format result and has format formatter. Okay. So we can do that. Use standard format display, formatter, and result. Maybe not result. Maybe we want format result so it doesn't interfere with any other result we have. And then we can say impl display for tree node fn format self f formatter format result right bang. Okay, so this is actually what we're going to I guess we could try to recursively do this, because self is going to have a left and a right. And so what I want to do is say for the node at a given number, if self dot val i32 min then we'll just print none. Or maybe we don't print anything at all. Can I do that? Right bang f, and then we just print out self val with a left and a right. And then we can recurse into left and recurse into right. And then maybe we can see what the tree looks like that way. Self val. Self val is an I32, right? Yeah. And then, oh, let's do left. If self left, if let sum left equals self left. Maybe we do it this way. This is an option RC ref cell. So we say left dot borrow dot val, else format bang, We want it to be a string, so I can just put this as a null value. And then we do the same thing for right. And then we can say left and right. Yeah? Let's see what blows up. Doesn't like that. Oh. Well, we can fix this. This should be standard format. And and that's that too. Okay, so now if we switch over to our what was it? Diameter binary tree. Let's try printing this out without the debug and see what it does. Oh, I have to unwrap it. Okay. Tree dot unwrap borrow. As ref unwrap borrow. Okay, so it's printing out 4 and a -7, -7. Does that work? No, it should be -3 for the right-hand side. Which makes sense because I did this. Right. 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 There we go. So let result equals this, semicolon, and then we want to print out the left and the right. Should I just call format? Wonder if I can call it here. I don't know if I can just do this. I'm going to try it though. Left, comma, left borrow, comma F. And there's right borrow, comma F. And it should be right line. Oh, without the dot there. Cell format, okay. Expected one argument, but it takes, oh, right, cell format. So I should actually say left borrow format F. And now we have an else problem here. Oh, because I didn't do this. Okay, let's take that away. There we go. So the bottom, we have a -7 with left and right of nothing. We have a -1 left and right of nothing. Okay, so our top of the tree is a 7 and -3. We have a -3 with a left of -9 and a right of -3. We also have another -3, which must be this guy, right? Which has two -6s. This -6 has a -2. This -2 is the bottom of the tree. Okay, so we might be able to build it up that way. And let's see what we got wrong, because we should be able to do this row by row. Let's find out. Let's find out what this should look like based on this. So we have a 4. 4, there we go. And then we have a 7 and a 3 for the next row. I'm spacing these out because I don't know how big the tree is. And then we have a null, right? A null, a -9, and a -3. And then we have the next level. So these are nulls. So this 9 should go here. and then -7, and then -4, and then null. Oh, okay, so this 6 goes here on the 9. And we don't have a 9. Okay. Yeah, I think the way this is supposed to work is we skip over these guys because those are nulls, and we come here and say this is 6. So I'm building the tree wrong, which means this test we can't use right now. And I need to fix the tree code. For simple trees, I guess it works fine. And then when we get more complicated trees like this one, right, this should work with, so that's 974 null. And then this should be 6 and null. And then this should have -6 and -6 onto there. And then these two should be nulls. So yeah, how does that work then? Because we shouldn't have to do that. Oh, yeah. Those are 2 nulls. And then we come down here. And then this is 0 and 6. And then this is 5, null. 9, null. Yeah, okay. So this is a more complicated tree, and we messed up building it. All right. So I'm going to leave it like this then. Result that must be used. Oh. I guess we can just question mark it out. Yeah. And we have too many new lines. Okay. All right, I'm gonna leave this like this because this will be kind of useful for figuring out how to debug this later. I'm gonna have to investigate the right way to do this, and then I'll do that on stream for the next stream. Git commit -m, add some output for the tree node. Need to debug tree building. Because if we can't build a tree for the test cases, then it's hard to actually do any debugging. I got lucky this time because I was able to reason my way into the answer with the diameter of the binary tree. There's basically the maximum, whichever is the biggest, the right diameter or the left diameter or the sum of the heights. Because the sum of the heights is the path through the longest path through the tree for a given subnode. All right, that's done. Let's check that box and put it behind us, and then we'll figure out the tree node thing another time.